Okay, in this video I just want to discuss the peptide bond a little bit before we start drawing, tripeptides, tetrapeptides, etc. So, a peptide bond is also known as an amide bond. It is a covalent chemical bond formed between two molecules when the carboxyl group of one molecule reacts with the amino group of another molecule, thereby releasing water. This is a hydration synthesis, also known as a condensation reaction, and usually occurs between amino acids. This is just a basic definition I took from Wikipedia. And to go along with it, I just wanted to kind of show the formation of an amide bond, so a little bit of organic chemistry here. So, I'm just going to draw some stuff here, and then I'll show you what I'm thinking about doing. So, first I'll just draw a carboxylic acid and an amine group. Now, the thing we might remember from organic chemistry is that this is delta positive, and this is delta negative, and this has a low pair of electrons. So what can happen here is we can attack right here and kick that up with an arrow up like that. And what we wind up with is a pretty high energy tetrahedral intermediate. So I'm going to show that. Negative charge on the oxygen up here. And then we have N, the R group, H, and another H. And this has a positive charge on it. So I don't know if you can see that too well, but that's a positive charge. Now, the thing about this is that, yes, this group is a much better leaving group than the OH. And it does happen that that group does come on and leave. So that amine group does come on and leave at, various times. But every once in a while something else can happen. And what can basically happen here is that this negative charge here, we kick back down, and we can kick this off. Because really this tetrahedral intermediate is very, very high energy because of the charges, especially the negative charge on the oxygen. So what we wind up with here, and I'll go this way with it, is reformation of the carbonyl group and this here, plus OH minus. And to really finish this off, the last thing that will happen is that this OH here will take a proton. From here, we'll kick back onto there, and we'll move over here. We'll just wind up with the amide. That's on charge now. So that's basically the general mechanism for how to form this bond, a very basic one. And now that we kind of understand a little bit about what's going on with the peptide bond, I have here a problem that says draw a tetrapeptide, tyrosine, asparagine, leucine, methionine at physiological pH. So you might recall that physiological pH is equal to 7.4. So again, this is where it might help you to have the chart in front of you to show you what's going on, see what's charged and what's not charged. And the next thing to do here is just start drawing out the peptide. So we have the amine group here. Again, just the backbone. And this is the alpha carbon. So I'll draw my tyrosine, CH2. And if we recall from the last video, or maybe not, that tyrosine side chain has a pKa of 10.5, so since this pH is equal to 7.4, it's going to be protonated. Now, we got the carbonyl group here, and that's where the amide bond, or peptide bond, is formed, NH. So we draw the next side chain, which is asparagine, CH2, C, double bond O, NH2. There's that side chain. Now again, same thing. Form another amide bond here, and we'll draw leucine, which is CH2, CH, CH3, CH3. So there's leucine, and now again we'll draw this C, H, and the last one's methionine, which is CH2, CH2, S, CH3. And on the end here, we'll have a carbon, double bond O, O minus. So that's your tetrapeptide right there. Nothing really spectacular, just recognizing that this is your peptide bond and that the backbones are all in place. And another thing to recognize is that it goes from the N terminus to the C terminus. And that's about all I wanted to say for this video.